A while back, somebody asked me if I knew how to make a motor stop at a certain time and then go again. And I tried a few things with some different timer relays, and I couldn't really figure it out, make it work properly. And so, someone that comments in my videos, I contacted him, asked him if he knew how to do that, and he figured something out. He sent that to me and the other individual, so he figured something out. And so I've been trying to duplicate it, and I haven't had any luck. But he introduced me to this type of timer relay, and so I've been playing around with them, and I've got it working a few different ways here. Like you see a couple extra relays here. Reed switches can't carry the load to trigger the timer relay, so this little Bosch relay can, because it's only 0.1 of an amp, and the reed switch will carry about 0.5. But this type I got off Amazon, they fry very easily. So, and then if this relay couldn't carry the load, or you wanted to trigger something, that's why I just put another relay up here in this particular picture. But we're not going to go over how these are wired. We're going to do it a couple of different ways. So with here, this is my first experience with transistors. And I don't believe transistors are that difficult. But watching videos on YouTube and trying to figure out how transistors work made it difficult. So that's why this is a real basic video. So if you're more advanced, this video is probably not for you. The good thing is no smoke came out of anything, so I think I'm doing it okay. So we're going to show the timer relay base here. And with the notch at the bottom, the two outside are your coil wires. The two middle ones are the common. So the one on the right side connects to the top two on the right. And so that's where I've got the positive hooked up for the motor. And then here's the timer relay that I'm using and the diagram on the side of it. And then here you can see more of the wiring where my positive junction here is where it's connecting to those three terminals on the right. You can really switch whatever you want. My background, I switch a lot of positive circuits, so that's just my background. Okay, we're going to wire this up. In this version, we're using a reed switch and a Bosch relay. He wanted to control it with reed switches. That's why we're using reed switches and not a different type of switch. Of course, you could and then use a switch that can carry the load of the timer relay. So the two positive wires coming out of the timer relay go to the positive side of the motor, and then the negative side of the motor goes right to the negative junction point. Then I'm going to switch the relay with positive, so I've got positive coming out of the junction point going to the common of the reed switch, and then the normally closed going out of the reed switch to one side of the coil, 85 or 86. And then we need a negative from the negative junction to the other side of the coil. Then we need a negative going into, in this particular case, it's going to 30. And then 87 will go to the timer relay. So when the Bosch relay gets energized, it'll close and send a negative signal to the coil on the timer relay, triggering the timer relay. Okay, I'll see if I can try to explain how this works. I'm new to this type of relay, but I've been playing with it now for a while. And so we can see on the meter here that when I supply power to the junction down here, this motor would be turning. I have it disconnected right now. Okay, but you can see nothing's happening here. We're in mode B, and I have voltage here, so the motor would be turning. Once the magnet reaches the reed switch, it would start the timer. And you can see the voltage stops here. Okay, and as long as the magnet is by that reed switch, there's no power on this side. But once the timer times out, it puts power to this side. So the motor would be turning again, which would move the magnet and resets this relay. So now you can see there's no power here, but there's power here. So I hope that makes sense. It took me a little while to figure that out, but it makes perfect sense to me. So once we get the magnet to move, we can reset the relay. See, and every time the magnet goes by the reed switch, it starts that over. So these are just switching back and forth, the power to move the motor and to stop the motor. So my main powers are coming in. I'm just using this 12-volt battery I have. So my negative comes into here. I'm positives coming into here, and I just have a switch on it to get the whole process started. Okay, here's a wiring diagram. So we have the two motor leads, positive motor leads going here, 4 and 6. We have positive going to one side of the coil, positive going to the common, positive going to the common. Our other positive is going to go over here to the common of the reed switch. So when the magnet reaches here, this switch will close, sending power to the coil on this relay. This relay is here because this relay is too powerful for this reed switch. Okay, this reed switch can only pass so much current through it. This one draws a lot less. So I'm able to use this one to trigger this one. That's why we've got so many relays going on here. If you had a different switch, this person wanted to use reed switches, so I've been trying to figure this out with reed switches. But if you had a different switch that could carry the load of this, then you would eliminate that. So once that powers that coil, we've already got the negative on the other side of the coil. So that's there all the time. This one's only there when it gets switched here. Then we have negative going to one side of the relay, which that terminal is, I think, 87. This terminal is 30. So normally if I was wiring this up for a more permanent basis, I would put my input on 30 and then my output would be over here on 87. And then these are 85 and 86 are your coils. So once this is energized and this switch closes, these two make contact and then it triggers this relay here, which starts the timer, which opens both of these circuits. So these circuits would not be getting positive at that point. When the timer times out, as we saw in the video, this would get power until this de-energizes, which that happens once the magnet moves past the reed switch. This no longer has power. This won't have power anymore, and this one will. So this will get it kick-started, and this will keep it going. So a lot of the videos on YouTube were pretty confusing. This is not going to be a video of the engineering part of a transistor or how to engineer a circuit. This is real basic. So if you're looking for that, there's plenty of videos for that. But I did find this one thing online that I did like that I think will help beginners. And it says a transistor is comprised of 3 legs, with the base being the tap, the emitter being the faucet, and the collector the tank. So they're kind of using a plumbing metaphor. By controlling the tap with a small force input signal to the base, a large amount of water flows from the tank, which is the collector, to the faucet, which is the emitter. So B gets that small, you're going to have a resistor there that's going to get that small amount of voltage or amperage, and then C is in and E is out. That's how I look at it. So I'm just getting into learning these transistors. I watched a couple dozen videos on these. Most of them just made me confused. This one's a PNP, it's a BC327. This one's an NPN 2N2222. I know this one's pretty common. And basically, when you have the flat side, how this has been working for me is that this is your input, this is your output, and the middle one's your trigger. And so an NPN to me is negative, positive, negative. That's how I'm looking at it. And a PNP would be positive, negative, positive. So if we put this one in here, so we want that middle leg to be where the resistor is. So you have to have a resistor. You need a small amount of current to go through that middle one to be able to pass current through the outer two. Okay? So this is going to the out. So this is going to go to our relay. This here is just input, and then I've got it crossed over to here. So this will be a positive into that side. This will be a negative trigger from the reed switch, and this will be negative out to here. So we'll start with the PNP diagram. Start with the negative circuit. So we have to put a negative to one side of the motor. The positives are switch side, so this can get negative straight to there, negative to one side of the coil on the timer relay. We're going to be triggering this with the negative. So this goes to the common of the reed switch. When the magnet gets close, it closes and sends negative signal here. Then on our positive, we have to go to the left side here. That's our input. And then this is our output. That'll trigger the relay here. And these are the same as all the other versions. So we have our positive going into the commons and then out to the motors. So once again, when that closes, sends that small amount of voltage here. I'm using a 1,000 ohm resistor. If you need to know how to size a transistor and what size resistor, I'm not going to do that in this video. I'm still learning about transistors, but there's hundreds of videos to watch. Most of them for me were confusing. It took a while before I actually can make this work, and it's simple. I mean, it's working. I'm assuming I'm doing it all correctly, but it's working great. So that's the PNP. And I look at these as positive, negative, positive. So they call these something else. And so here's the NPN. So negative, positive, negative. That's how I'm remembering it. So our negative, we just have one going to the motor, right? Positive is our switch side. Negative going on the left side. This is the flat side. And then this is our output to the coil, negative side of the coil on the timer relay. So our positive is going to the common on the reed switch. Our output is on normally closed through the resistor to the center. And then we have positives all feeding here. So these are our commons. That's the other side of the coil. This is our switch side. And then out to the motor. So in a permanent installation, this I'm just testing and trying to do proof of concept, you would probably need to put the diode across the coil part of the relay. So I'm going to grab positive here from the junction. And this is my positive in. That's actually the one that's on the left side there. These are just all temporary connections just so we can test this thing out. I'm not going to change the colors on these. Okay, so the negative because we're switching positive, is going to have to go right into the junction. Okay. So positive in, and so this side here, this is the side we're going to trigger now. Because we're switching positive with this type of transistor. And then this one here with the resistor, and this is actually the trigger from the reed switch, which we have to change its input. Right, so that's going to send power from the reed switch, but we need to switch this over to negative. Okay, so now when the magnet gets to the reed switch, it's going to send a negative signal, even though I got red wires here. Okay, that's going to send a negative signal to the center of the transistor, passing the current through the positive side. Turn the power on. And there it is, it's operating. So now this reed switch doesn't have to carry the current from this relay. That's carrying the current. We're just triggering that transistor. So now we put an NPN in. I'm going to disconnect some power here until we get this all connected. Now the center post still goes to the resistor, but we have to change all the voltages here. Right, so now this one, this can stay here, but this one, we're going to trigger it with positive. So NPN, negative, positive, negative. So we're going to go positive input to the reed switch. On the coil, we're going to put positive back to the coil. This is going to be our trigger now. So our trigger for the coil is going to be negative. And that's going to be on the right side of the transistor. Okay, so let's make sure. And now the in for the transistor needs to be a negative. Okay, so even though it's a red wire, this is negative. Okay, so now I've got a positive trigger, so positive through the reed switch, positive trigger through the 1K resistor, and then these two sides have to trigger the negative side of the coil, and now this is negative in. So let's hook power back up. Magnet reaches, still operates. So like I said, all the videos I watched trying to figure out transistors, most of them are confusing. So obviously I'm not an engineer, I'm just trying to make stuff work. So you can see these are working this way. So we eliminated that relay with this type of switch. So if you're using a transistor or sensitive electronics, this type of relay or relay, when they disengage, they create a spike. across the circuit. I experienced this on a motorhome when they first started using LED lights, and they were using a relay just like this one to turn the electric water heater on and off. Anytime they would turn the water heater off, all of the LED lights in the motorhome would flash. And so what they used was a diode. So you want to bleed off that spike from the positive side to the negative side. So you're going to put your stripe towards the positive side of the relay. And I'm just doing this for demonstration purposes. That's why I've got it set up this way. So I've seen it online called a flyback diode. So if we hook up our relay, okay, across the coil, then we're just going to hook up a meter here so we can see that's not affecting how the relay operates. So you can see the diodes connected right across the positive and the negative. Okay, so when I trigger the relay, still operates, but it's going to bleed off that spike so it doesn't harm sensitive electronics. So that's my version of the timed stop and auto restart circuit. I really wanted to figure out how to do that, and I had a lot of fun. Learned a lot of new things, that new timer relay and playing with transistors. And I'll leave links in the top pin comment and in the description on where I learned a lot of that from. There's a YouTuber that comments a lot on my videos, and he's been very helpful. So go check those out too. Thanks for watching. We'll see you next time.